Infrastructure as code kind of gives you that robust foundation of guardrails where you almost like, you wouldn't vibe code without Git, right? And so I don't think you would use AI for your cloud infrastructure without something like Pulumi, where it can give you previews before it makes changes. It gives you full audit history. And that's ultimately what led to Neo and why, for example, we still lean into the MCP server and other integrations. We want to be better together with the tools that people are using, not replace them. And again, we got started on this over 2 years ago. When GPT first came out, we've been steadily adding AI features to the product. And at some point, we realized, okay, this agentic experience where it can actually take action as a virtual teammate is really powerful.
Tell us a bit about what we're seeing in the difference of how platform teams are changing with these tools.
It's interesting. I look back at the history of Pulumi, and one of the patterns we recognize is a lot of time, great things happen for application developers with programming languages and their favorite tools. And then there's a lag between when it goes from application development land into platform engineering land. So similarly, I think the AI adoption curve is a little bit behind where it is in application development land. Also, platform engineers have to do stuff that's not just pure coding, right? There's operational things, they have to deploy things, compliance fixes, diagnosing live site issues. And so it's a frankly more complicated space, but there's a lot of excitement about the possibility of using AI to automate some of those tasks.
Is that bottleneck increasing? And what are some of the kind of factors at play there with wanting standardization and security, but not wanting to slow down this application velocity?
Absolutely. I think it is getting a bit worse, and it will get worse before it gets better. I think some of the stuff we're talking about today is going to help with this. But we launched Pulumi IDP earlier this year. The goal was to accelerate developer self-service, so developers don't have to file tickets and wait for days or weeks or months to get their infrastructure. They can just spin up stuff on demand. But you look at the rate of innovation in these teams now where developers are just spinning up new applications left and right. I think AI has accelerated that. I was talking to a CIO the other day who's saying he's kind of terrified because in this new world, developers are writing way more code than they ever did before. Frankly, they understand it less than ever before because, the AI is writing a lot of the code, and of course they're code reviewing it, but sometimes you miss something. And yet all of that still has to run in the cloud. And we're not just going to forget about governance and security and compliance and cost effectiveness and all these things overnight. Just because of AI, we need to, stay in control on top of those things. And yet we don't want to slow down the rate of innovation. And so it's not, sort of a catch-22. And platform teams are the ones trying to figure it out and how to best move forward in this new world.
Makes sense. And so how are you seeing some of the existing tools you mentioned, like the existing IDE tools or agentic tools for software development? How are you seeing gaps there for how it's servicing the needs of platform teams?
Yeah, it's a great foundation. The models themselves are just so good, but it's really about the workflow, the context, the access to tools. I think one of the thought exercises I had, like late last year sometime was, okay, platform engineers have a brain and they have access to tools and they have access to information and context. Well, we've got the brain, which is, the LLM. What if we gave it access to all the tools that a platform engineer had access to and all the context? And you don't get that out of the box just with the tools today. Things like the Model Context Protocol, MCP, has given these extensibility points so that the models can gain access to this additional information, but it's not out of the box, right? You have to kind of stitch it all together yourself. And so, Pulumi, we have all of that context, all that data. We understand the cloud. We know which tools to run and how to orchestrate them. And so that's sort of the missing piece in today's tools.
I think a really interesting observation that we kind of made early on in building Neo for platform engineering teams specifically was they do want to use AI tools, but they need AI tools that definitely accentuate their workflows. And that includes introducing guardrails that accelerate their workflows, that don't impede them. Thinking of guardrails as features instead of impediments. Luckily, because Neo is built on Pulumi and the Pulumi platform, we have a lot of guardrails that we can just offer out of the box. Things like policies, things like IaC, things like IaC, that are those accelerants that platform engineers need to be able to leverage AI tools effectively and safely. We can demonstrate this in a very basic example, something that platform engineers deal with multiple times a year, and that's dealing with EOLs, or when a cloud platform like AWS lets you know that, hey, runtime version is no longer going to be supported. So let's take a look at how Neo would handle this, how it kind of discover the out-of-date runtimes, and how it would help you address them. So let's go ahead and take a look. Cool. So let's grab a prompt that AWS would actually provide you via email, and we'll drop that right in, completely unmodified. So I'll go ahead and feed that to Neo, get it started. So the first few seconds here, Neo will take some time to really understand the prompt that you provided it, kind of establish a plan for how it wants to tackle it, and then provide you an initial thought on what it thinks is the best way to accomplish this task. So pretty quickly, Neo was able to understand the prompt directly from the email that AWS sends out. And now it's asking you if you would like to proceed with upgrading any identified runtimes from 18x to the most recent version that Neo has identified, and let it keep working on the task. Great. So Neo has found 10 different instances of where we're using Node.js 18. It's also at the same time done a web search to understand the most recent versions, specifically the LTS version. What's pretty interesting, and to be honest, pretty cool, is it also noticed that the policies we're using to validate our Lambda code also are out of date, because they were also validating that Node.js 18 was being used. So we'll actually at the same time go ahead and propose code changes to upgrade our policies as well. So not only will our IaC code be updated, but our actual policy tests will be updated via the same pull request, which we'll see here later in the workflow. Now that Neo has made all of the changes, or staged all of the changes to upgrade from Node 18 to Node 20, it's actually offering to run a Pulumi preview for us automatically. So this way we can validate that no resources are being destroyed or recreated. We can also validate that our policies are still passing correctly so that we're meeting our organizational standards. So I'll go ahead and hit yes, and that will kick off a Pulumi preview using deployments, just to kind of give us that peace of mind and bring that signal earlier into the process. We've seen our previews run. It's demonstrating that everything is purely an update. No resources are being recreated. No resources are being destroyed. And you can also see that we have passed all of our policy checks. So everything is completely compliant. And Neo has handled all of this for us. So now it's offering to create a pull request for us to go ahead and make these changes. So we'll go ahead and do that. And then we'll take a look at what that pull request looks like. We look at the pull request that Neo opened for us. We see that it provides a lot of the helpful context that AWS included in their email as well, including why the EOL was put into place, the timing for it, as well as validation that proves that this check isn't going to introduce any breaking changes, the preview is successful, and that all of our policy checks ran as well. And so if we move over to actually look at the code that has changed, we'll notice two things. One is our policies. When they execute, we'll also now check to ensure that Node.js 18 is no longer being used. So moving forward, this isn't a problem we'll ever run into again, and we can continue to upgrade versions or prevent bad versions from being introduced. As well, the code itself for actually creating our Lambdas has also been addressed. So just in a few minutes here, we've gone from an email notification from AWS letting us know that a specific runtime version is no longer able to be used, to addressing that issue all without touching the code ourselves, and still having the confidence that we're not breaking anything. We're actually improving things by doing things like updating our policies at the same time as well.
And so that leads us to, how did we go about filling that gap? So tell us a little bit about Neo.
Yeah, so, we started getting really excited as we started thinking about this, and we had a lot of hackathon projects. One of them was, the idea was, well, what if, Pulumi has infrastructure as code, where you declare infrastructure in your favorite language, and usually that's Python or TypeScript or Go, C#, Java. But we had this idea, what if you could use natural language to actually just declare your infrastructure? And it led to some interesting, outcomes. It actually worked. So you define, you just say, hey, I want a web service running in AWS with a database and, some whiz-bang services around it. And it kind of worked. But the problem is, platform teams have to deal with a whole lot more than just spinning up infrastructure. In fact, when we talk to customers, it's things like, hey, my company now needs to get compliant for, ISO this or high trust that. And my goodness, there's just so much work to get done and thousands of violations. And then there's, things like rolling out provider upgrades or upgrading your Kubernetes clusters. Like that can take weeks to go through a Kubernetes upgrade. And isn't that fun? There's so much toil and so much stuff just sitting there waiting to be automated. And so that was the thought process of, hey, if we really did personify the models and give it access to context and tools and bet big on the latest and the frontier models, can we actually automate a lot of those, platform engineering workflows? Can we save end users time, bring them more joy in their daily life so they don't have to work on thankless tasks? And, oh, by the way, would things like infrastructure as code, policy as code, secrets management, all the great stuff that we already have in the Pulumi platform, would that be the thing that makes it go from being a killer demo to being something that actually works in practice?
And a lot of the collaboration stuff that comes with it of, if this is spanning many repos and doing things like upgrading your Kubernetes clusters, you probably want a lot of eyes on it, right? And so tell us a little bit about how we're thinking about the human in the loop side of this.
We really think that the guardrails are going to be the key to making this work in practice. That said, our dream is that more and more of this becomes autonomous, especially as our agent gets better, as the models get better. Wouldn't it be great if you just woke up in the morning and Neo had already found a bunch of cloud waste and saved you thousands of dollars just automatically? Or you didn't have to ask it to go work on your compliance violations. It just knew, okay, my company needs to be compliant, so I'm going to ensure continuous compliance. And so we architected Neo to support full autonomy, but especially knowing where the state of the art is today. And let's be honest, we don't necessarily trust AI with the full keys to the kingdom just yet. And so we really started with the autonomy slider all the way to the left, where the human really is in the loop. So if you say, hey, upgrade my Kubernetes clusters, Neo's going to go figure out a plan and come back and say, hey, here's what I think I should do. Does that look right? And then the human can say, hey, no, let's not do 50 Kubernetes clusters all at once. Let's just start with development and make sure it works and there's zero downtime. And it'll just go back and forth with the human. And again, infrastructure as code gives you such an important building block, because just like when you're vibe coding and it shows you the git diff, in Claude Code, you're going to get that with the Pulumi preview for the infrastructure changes. So you always know what it's going to do before it does it. We wanted to meet people where they were. So we bet big on sort of that source code oriented workflow. And in the future, we'll have additional things that Neo can do outside of the context of source control. Like we're going to give it access to operational data like your logs, and it will be able to go update Pulumi Cloud to configure things like deployments. So not everything over the course of time is going to be done through source code, but as much as possible, we want to keep it kind of oriented in that direction.
How are you thinking about the future of code and the role that IaC plays in that?
I'm probably a biased person to ask that question because my entire career has been around code, right? Like I led the languages teams at Microsoft. I just love programming languages. That's been like my passion for over 20 years. And so I think code is here to stay. I think the nature of how we interact with code is totally fundamentally changing. And I'm not so naive as to think that the interface between the AI and the machine can probably be optimized in certain cases, in certain scenarios, and code may be a useless artifact because code is designed to give the machine, the computer, an interface to human beings that is palatable, right? And easy for us to manipulate and work with. That's not necessarily the thing to optimize for going forward. So I think you will see new programming language constructs that are more about the AI machine interface.
Okay, so I'm going to ask you what I think is probably on a lot of people's minds. I'd love to hear from you. Like, how are you thinking about that role of it being a teammate versus replacing someone on your team?
Yeah, so it's absolutely a teammate, and it's absolutely not going to replace you. It is better together, and that's why we designed it with so many kind of human in the loop controls. But it really allows the human platform engineer to spend their time on more strategic things, less toil, more value add, and more automating away the toil, with Neo. And over time, it will become more autonomous and more capable of doing things that, offloading tasks from the human. But it is definitely better together, and it's not going to, replace, actual human platform engineers. And I think really leaning into the fact that it's sort of an agent on your team that you can offload tasks to, you can assign it things, you can interact with it like you would a teammate. I think personifying it helped us build it.
Something that's been put into perspective for me as we've built Neo is the scale that our platform teams have to deal with as they're utilizing tools. One of the reasons we built Neo is to help them deal with that. Take, for instance, not only the sheer number of resources they're dealing with, but even the logical size. If you take into account the number of IaC repositories that they're using and putting code into, the average at Pulumi is over 20 repositories, whereas our largest customer is actually using over 230. The sheer scale makes any change hard. It's not just understanding what is the change that needs to be made, but more so, what is the change actually going to impact? And that's one of the reasons we built Neo. Let's take, for an example, an organization that wants to centralize all of their connectivity through IaC. They want to make sure anyone connecting to a database, Tank, is doing so using IaC. First, let's understand how any of the applications are actually connecting to Tank. Let's understand then how we can then transition them to be using IaC instead. You can see initially here that Neo has quickly been able to understand what the Tank database is, how it's defined, and where it's located within Pulumi, so they can start looking across your entire organization to understand where it's being referenced. Neo has identified 5 repositories that it is used throughout the organization. It is now going through the files and identifying places that are referring to the Tank database. After some digging, Neo comes back with a summary. Across the 5 repos, only one, Trinity, is connecting with Tank, and it's doing so with environment variables, which we don't want. So instead, let's ask Neo to switch over to using IaC. It's confirming now that it's understanding that we would no longer like Trinity to use environment variables, but instead it should use Pulumi IaC for connecting to Tank. So it's made the changes, it's proposed them, and then now it's asking us to run a Pulumi preview to verify that they work. Great. So after running a preview and verifying there's no policy issues or breaking changes, we can open a PR. Once the PR is open, Neo recaps the work it's done. It's found infrastructure connecting to Tank without using IaC, switched it to using IaC, modeling it after an original implementation, and filed a PR.
Moving from just doing these tactical, oh, I need to go do this immediate ticket, to those big picture things on platform teams that they want to get to is kind of, where we're wanting to lean in, is that level of support for them.
Yeah, totally. And, I think a lot of our customers, it's not that they don't have the information about what needs to be done, right? In the last year, we added the ability to point Pulumi at all of your cloud accounts, regardless of how you're managing the infrastructure, whether it's Terraform, CloudFormation, manual point and click in the console, and we can just hydrate those resources and show you them, and you can search and filter, and now you can run policies over them as well. And we were talking to a customer recently, and they said, wow, we just had no idea we had so much of a backlog here. So, okay, they know about it. How are they going to take action? Like they don't have enough human capacity to go and actually chase that down. Now with Neo, just, sign as many as you want in parallel to Neo, and it's going to chug away and try to do its best job.
That does remind me of one of our very large customers who's going through a big project where they have a lot of issues due to some compliance requirements they have. Maybe give a little bit of detail on how that informed our thinking for Neo.
I was like, hey, policy really could be sort of static analysis for the cloud. And I added that in basically on day one for no good reason. And then for years, we kind of just didn't really invest in it, and it's just kind of sitting there. But over time, we started to realize that's a really important guardrail, especially in an AI first world, because if AI just knows how to follow compliance guidelines as it makes the changes and Neo can just do the right thing, not only can you make sure you don't create future debt, we can actually start burning down the existing debt. And so some of these customers, they frankly have no hope in actually getting compliant if it weren't for something like this. But Neo is designed to do things that previously took weeks, upgrading many Kubernetes clusters across many environments and potentially multiple repos. And a lot of the tools today are very single repo centric for good reasons. A lot of the performance tuning that's happened, having 100 repos or something is actually an engineering challenge and a scale challenge for those tools. Whereas Neo was built to handle that level of scale. But they really are better together. We envision people will be doing, IDEs, Cloud Code, going into the Pulumi Cloud Neo experience.
And so it's kind of, to your concrete example, allowing you to expand across the organization, but do these long-running tasks. And similarly, I imagine you could also say in a month, hey, go do this again. Come back to that task and organizationally go fix that issue again. So I imagine workflows like that become possible.
Absolutely. And, you don't want to be sitting in your editor waiting for, Neo to go do 20 different things and waiting to get approvals and, creating the PRs. It really is more of like an asynchronous long running activity. And to your point, you may want to do it again down the road. You may want to actually schedule it to happen on a regular basis, right? You may want this thing to happen daily or weekly or monthly. And, again, kind of you touched on other teams might get involved. And one of our design principles was that we want to integrate with where teams are in terms of their release pipelines.